imagine you're working on this, like, massive heavy-duty machine, right? And you hit the power switch, the gears grind to a halt, the humming completely stops. It feels totally safe.
Right, because usually it is.
Yeah, but what if that machine operates more like a nuclear power plant? I mean, you can't just flip a switch and make all that stored energy just disappear.
No, absolutely not. The energy is always there. It's just waiting.
Exactly. And that is exactly what it's like working on a high-voltage electric vehicle battery. So, welcome to today's deep dive into electromobility safety fundamentals.
Yeah, we're going to be drawing heavily on the teachings of electromobility trainer Rolandus Remdeka. He's from qbsite AB.
Right, and our mission today is to really explore why working on high-voltage EVs requires this, like, complete mindset shift for technicians.
Because you absolutely have to treat the traction voltage system, which is also known as voltage class B, by the way, as live until it is manually verified dead.
And just to clarify for you listening, voltage class B means anything over 60 DC volts, which is definitely enough to cause fatal harm.
Oh, yeah, it's a massive shift in how you have to operate. I mean, electricity is basically a silent force. You can't see it, you can't hear it, you can't smell it.
So your intuition completely fails you.
Exactly. And since you can't simply unplug this power source to guarantee it's off, you have to measure it to know if the installation is safe to touch.
But that introduces, like, a pretty terrifying variable. What if your meter is just lying to you?
Yes, that is the big question.
It's kind of like looking at your car's fuel gauge, right? If it reads 0, you just assume the tank is empty.
Sure.
But what if the gauge itself is broken? You're basically stranded. And in high voltage work, trusting a broken 0 reading on a voltmeter could literally be fatal.
Which is exactly why Rolandus Remdeka emphasizes this life-critical routine called prove dead. It's vastly different from just, probing a wire.
Okay, so how does the prove dead routine actually work?
So first, you keep all your required personal protective equipment on. Don't take it off. Then you test your measuring instrument on a proving unit.
Wait, what's a proving unit?
It's basically this pocket-sized battery that generates a safe known voltage. You use it just to prove that your meter can actually read a voltage.
Oh, I see. So you check the tool first.
Right. Only after that do you measure the EV for hazardous voltage. And then finally, and this is the most crucial step, you must test the instrument on the proving unit again.
Okay, so you're basically bracketing the actual measurement. Like, you prove the tool works before you start, and then you prove it didn't just break during the test.
Precisely. Because if the meter broke at the exact fraction of a second you touched it to the vehicle, it's going to read 0.
Wow. Yeah, a failed meter showing 0 is just a classic deadly trap.
It really is.
But, that makes the mechanics of the test clear. What about the human element? Because even with a perfectly working meter, human error under stress has to be, like, a major factor.
Oh, it's a huge factor.
Yeah.
So during qbsite AB's high-voltage training simulator sessions, students will sometimes measure a massive 600 volts DC on the system. But because they're so stressed, they actually accept that 600-volt reading as okay and just proceed as if there's no traction voltage.
Wait, really? They see 600 volts on the screen and they just keep going? Why does their brain normalize that?
It all comes down to the psychology of measurement illiteracy. I mean, they're so focused on just completing the physical checklist of getting a reading right.
Yeah.
So the brain just stops processing what the number actually means. They see a number, assume the machine is doing the thinking for them, and they move on.
That's terrifying.
Yeah, they have to be actively coached out of this tunnel vision.
I could see how it's tempting for, like, a rushed technician to think, look, I've got my thick insulated rubber gloves on. I don't need to overthink this whole prove dead routine.
Right, the physical barrier.
Yeah. Isn't throwing on insulated gloves a foolproof safeguard? Like, why isn't that enough to make a bad meter reading irrelevant?
You'd think it'd be a simple checkbox, but that reliance on gear creates what the industry calls glove culture, and it provides a very dangerous false sense of security.
How so?
Well, technicians often test their gloves for leaks just by bending the fingertips. They completely ignore the rest of the surface area.
Oh, wow.
Worse, they wear these insulated rubber gloves while turning wrenches for non-safety tasks.
Ah, so they're exposing the gloves to, like, grease and sweat and micro tears.
Exactly. All of which rapidly degrade the insulation. So the physical barrier is structurally compromised before they even reach for a live wire.
That is wild.
And furthermore, your gear has to exceed the nominal limits of what you're working on.
Meaning what, exactly?
Well, a 600-volt DC system can actually spike up to 750 volts DC during charging. It depends on the cell chemistry.
Right.
So if you're only wearing 600-volt rated protection, you're in immediate danger. You need at least 1,000-volt rated gear for that system.
Which brings us back to the reality of standing on the shop floor, right?
Yeah.
When a manager or a customer is just pressuring you to work faster, it sounds like true safety requires actual professional courage.
Yes, absolutely. There is only one acceptable answer if your gear isn't right or, if you just aren't sure.
Which is?
You say, I do not have the right tool today. Period. No compromises.
That flips the whole perspective. It's not just about compliance, it's about drawing a hard line.
Exactly.
So for you listening, if you are ever just a little unsure, step back, verify, and reassess. Remember, orange identification on these vehicles means high voltage awareness. Do not touch if you do not know.
And if there's one closing mantra to take from qbsite AB's training, it's this. Work and design as if your own children will maintain the system tomorrow.
Wow. That is a really powerful standard to hold yourself to. And, it makes you wonder about the invisible risks outside the garage, too.
What do you mean?
Well, if surviving high-voltage work means we can never blindly trust a digital readout, and that a 0 doesn't always mean safe.
Right.
How often are you accepting a 0 reading at face value in other high-stakes areas of your life without ever verifying the instrument itself?